Hello and welcome to my presentation. My name is Kuhu Gupta and I work as Data Visualization Engineer at Illumio. We are a network security company helping enterprises segment their networks to enable better policies, hence making their systems secure. Today, I'll introduce you to Portola, which is a hybrid tree and network visualization technique for segmentation. I'll be briefly covering the background, followed by design process of Portola, then wrap the presentation with discussion and conclusion, and finally answer any questions. Today, 60% of organizations lack visibility into their cloud solution. Lack of visibility is a significant obstacle to security teams implementing threat detection and investigation practices. However, this is great news for visualization researchers. At Illumio, we protect customers by restricting attackers' lateral movement and reducing attack surface with more granular control through microsegmentation. We can think of it as a submarine using a compartmentalized structure. If there is a breach, it will remain contained to a single compartment where it occurred. Thanks to the segmentation of the vessel, the submarine does not sink. In the context of our IT environments, microsegmentation breaks data centers and cloud environments into smaller segments. Segmentation has traditionally relied on IP addresses, but lately it is using labels to increase effectiveness. Human readable labels simplify segmentation like application name, the workload role, and stage in a development cycle. These multi-dimensional labels are attached to workloads to build a contextual network, grouping nodes based on the label sets. This is also the basis for building and testing microsegmentation policies to allow or block the traffic flows. Currently at Illumio, we offer 4 labels: location, environment, application, and roles. Each source and target node in a computer network belongs to one or more segmentation labels. Different types of label hierarchical organizations can be built to describe the network nodes. In this paper, we only use one single hierarchy organization. The traffic between any two nodes can be routed through ports, and two nodes can be connected through multiple ports. Here, this is a snippet of a traffic flow data. Each row is the flow which has source IP and target IP with its associated label, as well as port, protocol, and process information through which source and target talk. Inside the security team of an organization, people perform different tasks as a part of their workflow. Application owners define security policies on an application by application basis. Risk and compliance officer analyze system level security policies to protect system information by access controls. An auditor conducts traffic flow audits to ensure compliance to information security policies and risk mitigation efforts. After identifying the user and user's task and reviewing existing microsegmentation and Illumio tools, we synthesized 4 essential design requirements to inform our final design. An overview is an essential segmentation task as it helps to understand the network topology and identify critical patterns. Users often have to do exploratory analysis where they are not sure what to look for in the network. After users have identified an item of interest such as high volume port, they want to see that node in isolation and more detail. Critical core services are the ports where the number of source nodes is significantly higher than the target nodes. Visually identifying these core services is an important task. Users want to identify anomalies in the connections and visually explore many-to-many and one-to-many relationships within the network. The design requirements and few precursor designs laid the foundation of a final design called Portola. Let's delve deeper into it. Portola uses an outward in-tree as a radial layered tree visualization layout, where the root of the hierarchy faces outwards and levels below the root go towards the center. Each label has certain nodes under them as each node has its associated labels. This forms a hierarchy, which is captured in the visualization. In first image, role label Ayastoa is selected on source side. You can see the parents of the role, HQ and staging highlighted. Secondly, the target nodes and its labels connected with the source role label are also highlighted. In the second image, on selecting a node that is an IP address, one can see its associated labels as well as all the connections with the nodes on the target side and on the ports they are talking to. Portola's network view connects leaf nodes of the source and target side of the hierarchy through the ports to present an overview of the network. The ports occupy the space between two semicircular hierarchy structures, source and target. The size of each port maps the total number of unique connections that pass through the port. With the size encoding, it is easier to spot the ports with the high and low volume of connection, which helps identify anomalies. The position of the ports node is determined by X and Y forces. The positioning force along the Y-axis aligns the ports based on port numbers. The lower valued port number for 3306 would be on the top, while the higher valued port numbers, that is 8983, would be on the bottom. Additionally, port nodes are positioned along the x-axis based on the number of the in degree and out degree of the ports. If the port connects to more source nodes than target nodes, the port will move towards the direction of the source nodes. The horizontal position of the node enables analysts to identify core services for the network. We will now proceed into the discussion part of this presentation. From our domain collaborators, we learned that splitting the information into multiple views wants the analyst to stitch together a cohesive view in mind, which can be error-prone and can lead to mistakes. Network data changes with time. Therefore, we want to extend Portola's layout to effectively show the change in the network and the hierarchy structure between two timestamps. The proposed layout is not tightly coupled within the domain. For example, in a geographical data set, entities such as cities, states, countries can be organized hierarchy to gather additional context. It is possible to have relationships between identities, for example, flight routes between cities. To conclude, Portola has been successful in aiding network analysts to audit network connections and identify anomalies in one cohesive system. Users can identify core computing services running on these ports through the port view. The Portola's layouts support uncovering the network topology and analyze connections between the highest and the lowest level of order within their network structure. It also facilitates drilling down on elements of interest while viewing the entire network topology and not losing context. The paper discusses design principles that broadly apply to design network security visualization and other domains that handle hierarchical network data. We believe this research could be a stepping stone for the next generation of visualization techniques for network segmentation. With that, I conclude and happy to take any questions.